Our fellow learners, this is Cameroon GCE Ordinary Level Chemistry 05015. In this video, we are going to start with June 2024, Paper 2. A kind reminder to all my subscribers and to those new to the channel that if you haven't subscribed to this channel, please kindly take some time and subscribe so that subsequent videos will get to you. Remember, my goal is that you should understand the basic concepts in chemistry and make you better students and future engineers, future medical doctors, future aerospace engineers, future pharmacy students, and future teachers. Thank you for taking your time to subscribe to this channel. Let's get started. June 2024, Paper 2. Section A. We are on Section A. The table below shows some elements on the periodic table. The letters are not the usual symbols of the element. We have the table. The table is there from A, B, C, and D. These are the elements. And we have the mass numbers that have been given, the atomic numbers that have been given, the proton numbers that have been given, the neutron numbers given, and electron numbers. Yeah, we are going to complete this using the letters that have been given to us. Remember, as I told you, the periodic table is like your Bible. Every one of you is supposed to have a good knowledge of the periodic table, especially the first 20 elements as required by the syllabus. So, question A, based on the data that has been given. Question A, complete the table above by giving the values of 1, x. Okay, looking at the periodic table, the value of x, the number of neutron. Just as I told you that most of this video is going to be on analysis, telling you, giving you the basic concept and making you understand the concept very well. Remember that when we're studying the atomic structure, there are some basic things we need to know. The proton number plus the neutron number gives us what we call the mass number. Protons are equal to the number of electrons. Remember, the difference in all this is caused by the number of neutrons. The number of neutrons is a player, it's a game changer. When you keep the number of protons and the number of electrons together the same, the game changer is only the number of neutrons. By adding the number of neutrons, it changes the game. So let's get back on board on the question. I'll complete the table by giving the value of x. X here from the element A. The element A has 35. The mass number is 35. Now the atomic number is equal to the proton number and equal to the number of electrons. So the atomic number is 17. The proton number is 17. The number of electrons are supposed to be 17. But the game changer is x. So we have, if proton number is equal to the number of electrons, then what should be y? Y should be 17. But we are looking for x. So, okay, x plus 17 equals to 35. Then what should be x? So 35 minus 17 gives you x. And what is the value of x? Okay. We said here protons protons plus neutrons equals to what? The mass number. The mass number. Now we have been given. So if we have the mass number to be we have the mass number to be 35, and the number of protons to be what? To be 17. And we are given the value of number of neutrons to be what? Neutrons to be x. So therefore, 17 minus this is 18. So our answer here is 18. Our answer for x is equals to 18. So let's write x here like that as given. X is equals to 18. Good. Why? I told you why the number of electrons are always equal to the number of protons. And that is why you have an atom that is neutral. A neutral atom is when the number of protons equal to the number of electrons. Protons are positively charged. Electrons are negatively charged. So when 17 and 17 positive and 17 negative electrons, they meet, what happens? It's a neutral atom. So the number of electrons are 17. Y is equal to 17. Y is 17. Yep. Now, Z, the number Z is here. Z is on element, Z, the letter Z is on element C. Okay, the mass number is Z. If the mass number is Z, and the atomic number, which is 3, equal to the proton number, and you know that the proton number must be equal to the number of electrons, and Z is the mass number. As I told you, the mass number is what? Is the number of protons and the number of electrons. The mass number is equal to what? The number of protons and the number of electrons. So now, for elements C, so the number of protons are what? 3. The number of electrons are what? 4. So 3 plus 4 gives 7. So Z is equal to 7. Letter Z is equal to 7. Let's go to B. Okay, B. Element A and element B are involved in bonding. Element A. Which is element A? Element A, if you go to your periodic table, the element with atomic number 12, you should know it. That's why I say you should have a way of having knowing the first 20 elements of the periodic table. For example, there is a simple song we can say, hey, he like beating boys coming near our field. New nation manage all simple problems, strictly claiming army knowledge carelessly. That is calcium. So if you have that version, you should know the first 20 elements. You don't need to go to the periodic table. So by doing like that, what is the element with atomic number 12? It's supposed to be magnesium. If you don't know that the element 12, this is how you can find it here. So, this managed. I say, hey, he like beating boys coming near our field. New nation manage all simple problem, strictly claiming army knowledge carelessly. Manage is what? Is magnesium with 12. With this, you can now say the element is 12, I say group 2 element, and you go back to your question. Element A, which is magnesium, element A, element A, which is chlorine, and element B, which is magnesium, are involved in bonding. So, okay, give the formula of the compound formed. Good. Magnesium is A. Look at it here. This is magnesium here. A, we are using by the we are using by the letters, please. A is a group 7 element. A is a group 7 element. So group 7 element, or what we call the halogens, they have a charge of what? They have a charge of the valency is what? -1. So they gain 1 electron. Now, okay, go to B. B is a group 2 element. B is a group 2 element, which is magnesium. So this is a B. Group 2 element have a charge of what? Is +2. Good. Now, give the formula of the compound form. For them to have a formula, okay, this is A plus a B. What do we have? We have a charge here of -1, which is, let me just say 1. And we have a charge here of +2, which is just say 2. So for them to form a compound, they need to swap their charges, or they need to just swap their valences. So what comes here is the 2 comes here and the 1 comes here. So what becomes the formula? The formula becomes A, 2, and a B. You don't need to write 1. So that is the formula, which could be written, which is, or you write like that, no problem, or you can write it as A, B, A, 2. No problem. Yep. So let's go back there and write the formula of the compound that is formed. So the formula that is formed here for 1, B1, you can either write it like this. You can either write it as A2, B, or you can write it as B, A2. No problem. A2, B, O, B2. So let's get to number 2. Name the type of bond involved. Remember that chlorine, which is A, is a nonmetal. And the B, which is a magnesium, is a metal. A bond formed between nonmetals and a metal is ionic bond or electrovalent bond. Because of the difference in electronegativity, chlorine is highly electronegative more than magnesium. It tends to draw electron towards itself. For that purpose, magnesium will donate all the 2 valence electrons to, all the 2 outermost electrons to chlorine, and an electrovalent bond is formed, or an ionic bond is formed. So the bonding there is ionic bonding. Ionic bonding, or what we call electrovalent bond. So now let's go to question number C, the C part of it. The C part of it, What is the C part of it saying? The C part of it, let me get this done. The C part of it. C, give the electron configuration. Give the electron configuration of elements. Give the electron configuration of element A. As I said, element A is magnesium. Chlorine. So using the Bohr model of electron configuration, this is what you are, and it has an atomic number of 17. Now this is the electron configuration of A. The electron configuration of A is this way. Here we have electron configuration of A. Now A has atomic number of 17. So in that case, A is A is the first shell closer to the nucleus has 2 electrons. The second shell, or the second quantum number, or the second energy level has 8 electrons. And the last energy level, or the valence electron, or the outermost electron, are how many of them? 7 left. So A has an electron configuration of 287. What of D? Look at D. D has has a mass number of 16. Atomic number of 8. Electron number, how many electrons are there? It has 8 electrons. With 8 electrons, or atomic number of 8, the electron configuration for D will be what? D will have, this is D. The first shell will contain 2 electrons. The second shell will definitely contain only 6 electrons. They are supposed to be 8 to respect the octet rule, but they are just 2, and there are only 6 that are left because it has an atomic number of 8, or it has the number of electrons that it has are 8. So it is only 2 and 6. Let's go to D. To which group of the periodic table does element C and element D falls? Remember, I told you, element C and D. Okay, element C and D. Okay, let's go. You will know it. I told you, that is how element C and D. Element C has an atomic number from the table that have been given to us. C has an atomic number of what? 3. If element C has an atomic number of 3, or the number of electrons are 3, this is C. So if it has an atomic number of 3, it means that what will be the electron configuration? The electron configuration of C, the first shell is supposed to be what? It's supposed to be 2 electrons, and only 1 electron is left. So we have only 1. So the electron configuration for C is 2, 1. Then again, electron configuration for D, because they say which group of the periodic table does C and D belongs? D, we said the electron configuration for D is 2 and 6. D, this is D, and it has an atomic number of what? Atomic number of 8. So the electron configuration will be what? It will be 2 and 6. They are asking us the group number. As I told you in my previous lessons, remember, the valence electron is always determines the group number of that element. The valence electron determines the group number of that element. For instance, the valence electrons, that is the outermost electrons. So this one determines the group number because the outermost electron is 1. It belongs to group 1. These are the S block elements. Here, because the valence electron the outermost electrons 6, it belongs to group 6 or group 16 according to the modern periodic table. So we go now. So C is 1 and the D is 6. Good. So C falls in group C. Group C falls in group what? Group 1. C falls in group 1. Oh, yep. And the D falls in group what? In group 16 or group 6. The modern periodic table calls it group 16, but some can still call it group 6. So D falls in group 16. Group 16. Group 16, which is formerly called group 6. That's group 16 is group 6. Okay, let's get to E. How would the element C be stored in the laboratory? Remember, reactivities of group 1 metals, they are highly reactive, and their reactivity increases down the group. They react with water violently, evolving a hydrogen gas, releasing a lot of heat. It's very, very exothermic. So, how would they be stored in the laboratory? Because of their reactivity, E must be stored under oil in the laboratory because of their reactivity. So we say must be stored under oil. Must be stored. Must be stored under oil. Must be stored under oil in the lab. Must be stored under oil in the lab to prevent its reactivity with oxygen. This one is just I'm just adding. So your answer is must be stored under oil in the lab. So you can just say to prevent its reactivity with oxygen. With oxygen in the air. In the air and water. This is just an addition for you for subsequent revision. So it must be stored under oil in the lab. That is just all. So go to question number 2. Question number 2 says, this question concerns some elements on the periodic table. This question concerns some elements on the periodic table. We have sodium, we have calcium, we have magnesium. Using the following elements, complete the table below. Now, give one physical property of group 1 metals. One of the physical property of group 1 metal is what? Okay, one physical property of group 1 metal is what? Let's start with the first one. Using the following element, complete the table. Group 1. The element in group 1 from this element that have been mentioned here is what? Is sodium. The element in group 1 is sodium. Excuse me. The element is sodium. And the general name given to all elements of group 1, we call them the alkali metals. Alkali metals. Alkali metal. This is an alkali metal. All group 1 elements are called alkali metal. Alkali metals. Then group 2 elements are called alkaline earth metals. Alkaline earth metals. So now, give one property of group 1 metal. One of the property of group 1 metal is that they are stored under oil. We just gave it up there. They are stored under oil. They are stored under oil. Another one is that if you don't know that one, you can still give another one like because of the space. Another one is they are soft and can be cut with a knife. You can attach it here. Let me say here like that, here that. Okay. Another property for group 1 metal is that here you can say they are soft and can be cut with a knife. Okay. Let's put it here. They are soft. They are soft and can be cut with a knife. So they are soft and can be cut with a knife. So you could also say they have very low melting point. They have very low melting point. Okay, they have very low melting point. Yeah. So now, we have 3 properties that I've given you. You can choose between any of them. In the examination, you can say they are stored under oil. You could still say they are soft and can be cut with a knife. And you could still say they have very low melting points. So you could choose between any of them and give your answer is right. Give one chemical property of the element of group 1. The chemical property is that, as I told you the other time, they are very, very reactive. They react vigorously with water to form a hydroxide and a hydrogen gas being released. So the property is they react vigorously. C. They react vigorously. They react vigorously. They react vigorously with water. They react vigorously with water to form what? To form hydroxide. You can say to form alkali. To form hydroxide. To form hydroxide and a hydrogen gas release. Now, in that case, you don't require to write equation. But if you were at the A levels, you were writing the A levels, I will recommend that you write the equation for it. At the A level, I would recommend that you write an equation. So you will have a sodium. You have a sodium here, sodium which is solid, plus water, very good, which is liquid, to give here when it reacts like that, what will happen is an alkali that is formed, that is sodium hydroxide. Alkali that is formed, that is aqueous, plus alkali is formed, plus a hydrogen gas that is being released. Let's balance our equation. You do like that. This is how you balance your equation from here. How many atoms? Let's look at this one here. Let's start with hydrogen. Hydrogen is okay. Let's go with oxygen. We have one oxygen here. And what do we do here? We put a sodium here in order to balance the number of hydrogen on the other side. So we put a 2 here. We put a 2 here. There will be a 2 there. There will be a 2 here. There are already 4 hydrogens here. On this side, there will be a 2 here. These 2 hydrogen are plus these 2. Oxygen here is 2. Oxygen here is 2. 4 hydrogens. 4 hydrogens. Everything is okay. And this gas that is being released. So that is how you are at the A level. That's what you are supposed to do. But now you have only been asked to give the property. So you can say they react vigorously with water to form hydroxides or alkali, and a hydrogen gas released. Hydrogen gas released. Sorry. Good. Now, D. The D part of it. So generally, it may not only be sodium. Generally, you can write the equation in this form. You can use the general equation. Let me just give a general equation that you can use in writing it for all metals that react with water. You can say generally. This is how metals will react. We have M, the form of a metal, plus water. Okay, plus water. To give what? To give 2M plus. 2M, that is 2 plus. Aqueous. Aqueous plus 2 plus OH. Plus that is 2 OH. Yeah, that's good. That is aqueous. Here, aqueous. And plus a hydrogen gas that is being released. Okay, now here the M is 2. You can put a 2 here. Very good. You put a 2 there. It's okay. So you put a 2 there. Everything is okay now. We have 2, 2, and we have, you can put a 2 here. Yep. Okay, 2 OH, and yep, 2 OH and 2 hydrogen here. You can put another 2 here. That's good. Yeah, 2 plus here. That's great. 2 here for water. Yep. And 2 M plus, 2 OH, and everything will be okay for that. So that is how you are supposed to do it. If it was generally, you were writing a general equation for all the metals, alkali. So they form the vigorously with water to form alkali, to form alkaline solution. Alkaline solution, the hydrogen gas that's being released. D part of it. Okay, write equation to show how these elements behave in water. Oh, I was already writing it. I've already written it, so there's no need. So these elements, if I want to represent this element for you, very good. I was writing it, answering it without knowing that the next question has it. Okay, now write a equation to show how this element behave in water. How is sodium behaving in water? If we have to follow the equation that was given above. This is how sodium behave in water. For sodium, this we have, just follow the general formula that I get there. Is 2, yeah, that is 2 Na, which is a solid, plus 2 water. Therefore, the general formula, you will see it there. And you have What is being produced? An alkali solution. Alkali, not alkaline, alkali solution. Sodium hydroxide, which is aqueous. That's a solution. That's why I'm saying aqueous. Plus a hydrogen gas that is released to the outside. Okay, now that is the general equation that you can write in such a situation. Then, if I'm to write equation for magnesium, what would be magnesium? Magnesium, magnesium. So magnesium will be this. You can write it as for magnesium, we are going to write magnesium, that is Mg, which is a solid, plus water, that is for magnesium. That is for magnesium plus water. This is supposed to be the water with magnesium. It is water vaporized reactor. It's not really liquid to give when heated. When heated, it is water. So to give, it gives you a magnesium hydroxide. A magnesium hydroxide. A magnesium hydroxide plus hydrogen. Which is a gas that's being released. Here, there is something here. You know, the water is a water vapor after the reaction. It's a water vapor that is being produced. It's water vapor that is being produced. So in that case, a steam. You have a G. A steam that is being produced. A steam that is being produced. And we will have here is not aqueous. What is being is magnesium hydroxide, which is later dissolved in water. So in this case, it's supposed to be a solid here that is being produced. So when you use magnesium reborn in the laboratory, you put it in water. After a period of time, the first thing is you have to heat it. When you heat it, magnesium oxide is being formed. After magnesium oxide is being formed, the magnesium oxide now in the water, you now dissolve it. What is being formed is magnesium hydroxide, which is a solid. So we have Mg plus 2 water and the hydroxide that is being formed. Okay, now identify a compound of sodium and chlorine commonly used in our homes. In our homes, we use some certain substances. Sodium, the common salt you use, the common salt or the table salt you use at home is what we call the sodium chloride. In chemistry, we call it sodium chloride. That is the common salt we use on our table. We use for cooking in the kitchen. So here we call it common salt compound. I say common salt. Common salt compound that we use is what we call the sodium chloride. That is the sodium chloride. A common salt compound that we use is sodium chloride. Okay, state the bond type in the compound in E. Remember, sodium belongs to group 1 of the periodic table. Chlorine belongs to group 7 of the periodic table or group 17, according to the modern periodic table. So a group 1 metal reacting with a group 17 or group 7 metal, what is going to happen? Because of the high difference in the electronegativity, there is going to be what we call an ionic bond. So the type of bond in E1 above is ionic bonding. Ionic bonds. So sodium chloride, we say sodium chloride forms ionic bonds. Sodium chloride forms ionic bonds. Now, question number, the F section of it says, okay, in the laboratory preparation of a gas X, sodium chloride, concentrated sulfuric acid, and the manganese 4 oxide are mixed together. Identify a gas X that is being produced. Identify a gas X that is being produced. You know, this gas is used in the collection of this gas. This one is used as an oxidizing agent. This gas is used as an oxidizing agent. Manganese 4 oxide is used as an oxidizing agent. It helps to absorb the water that is being produced in the course of the reaction. It helps to oxidize chlorine into a chlorine gas that is being produced. Meanwhile, the concentrated sulfuric acid is used to absorb the water that is being produced in the reaction. If you go to the paper 1 question, you saw we discussed this there. So, how does it happen? Okay, identify the gas X that is being collected. The gas X that is being collected, as I have said, I will show you in the equation that I'm going to write. The gas X that is being collected is what? Is a chlorine gas that is being produced. So gas X is chlorine. Gas X is chlorine. Yes. Chlorine gas. Yes. Chlorine gas is being produced. A chlorine gas is being produced. Now, what is the function of MnO2? I said if you go to our previous video, you will see in paper 1, this same question appeared there. So, manganese 4 oxide is, this is a transition element. And that is one of the properties of transition elements. They are used as oxidizing agent. They are also, they form color compounds. Okay. Used as catalyst. So in this case, this manganese 4 oxide is used as an oxidizing agent. So the function is Mn as an oxidizing agent. As an oxidizing. Is used as an oxidizing agent. Okay, for the purpose of revision, how does this work? I'm doing it because in subsequent occasion, you might still find it in your exams. How does this work? That is the question. Okay, let me write the equation for you. You will have something like this. This is manganese. This is manganese 4 oxide. Yeah, which is, plus in acidic solution, that is aqueous hydrogen. That is acidic, that is an acid. Usually hydrochloric acid. we have here in a solution plus the sodium chloride. That is where the sodium is. We have 2 Cl. That is where the sodium is. The sodium chloride we are talking of. And what happens? There is this is N2 plus. Yup, aqueous. That is the manganese again, which is a water molecule that is being produced. Okay, yeah, and the gas which is now produced is the chlorine gas. What you notice here is I said oxidation. What is oxidation? Oxidation is, in terms of oxidation number, we say it is oxidation number is an increase. I mean, oxidation in terms of oxidation number. This is an increase in the oxidation state or in the oxidation number. Even though we know that oxidation is the loss of electron. So being an oxidizing agent, you oxidize something and at the same time you are reduced. So here, if you look at here, this is this manganese here. Manganese here, if we are to look the oxidation number, manganese is +4. And chlorine here is -1. And manganese here is +2, you see it. And chlorine here is 0. So you will now find here that manganese has been reduced from +4 to +2. And chlorine has been oxidized by it. That is why we say it is an oxidizing agent. It has been oxidized. Manganese now oxidize the chlorine in the sodium chloride from -1 to 0, which is the gas. 0 is any element in its neutral state has an oxidation number of 0. So you see that this is this one is undergoing reduction, and this is going oxidation. So that's why I said manganese 4 oxide. Manganese 4 oxide is acting as an oxidizing agent, oxidizing chlorine to a chlorine gas. Because there is an increase in the oxidation number from -1 to 0. Let's get back on board. Question number 3. A hydrocarbon has a molecular formula of C4. A hydrocarbon is having, a hydrocarbon is having a molecular formula of C4H10. Write the general formula of the homologous series to which the hydrocarbon belongs. Good. If you look at it, the hydrocarbon, there are many hydrocarbons we have been dealing with, and by now you should know that hydrocarbons, we have different homologous series. For example, for the hydrocarbons are hydrogen and chlorine. Hydrogen and chlorine. Hydrogen and carbon and hydrogen. So for hydrocarbons, we have only carbon and hydrogen involved in it. So in this situation, we have CN, H2N plus 2. In that case, we are dealing with alkanes. But we have CN, H2N, we are dealing with alkenes. If we have CN, H2N, -2, we are dealing with alkynes. So let's see, which of the homologous series does this one belong? Okay, let's substitute the value. We will know whether it is an alkane or whether it is an alkane. So the formula is C4H10. Okay, C4. If we substitute C here, if we substitute 4 here, okay, carbon 4. Carbon is 4, that is C4. So the number of carbon here 4. So now we have 2. 2 times the 4 is what? Is 8. 8 plus 2 is what? Is 10. So H10. Does it correspond to that? Yes. So in that case, we will say, write the general formula for the homologous series to which the compound belongs. And the general formula in this case will be what? It will be, the general formula will be what? It will be Cn H2n plus a 2. That is for the alkanes. Name the homologous series to which the compound belongs. Of course, we have said alkanes. It belongs to the group of alkanes. Okay, now let's move further again to see the B part of it. C4H10 exists in more than one structural form. Remember, I told you last time, you should be able to differentiate between isotopes, isomers, and allotropes. Iso means the same. Iso means the same. But where it have different structures, the same molecular formula with different structures, iso means they have different, the same molecular formula, but different structures. We are going to isomers. Isotopes, we are talking of iso, the same. They have the same atomic number, but different mass numbers. As a result of what? Different number of neutrons. Allotropes, tropes, they have the same element, but different forms. Graphite, diamond, and the rest. Getting onto this question, this exists in more than one structural form. Draw and name 2 structural forms of the compound. Very good. Okay, we have in this structure here, in this question, we have 4 carbon atoms. So now the first structure will definitely be a normal butane. 4 means but. And we are talking of the anes. We are talking of the anes, butanes. So we are talking of butane, alkanes. These are under alkanes. So now we come here. Okay. Now the first one here should be what? The first one should have the structure of the normal alkane, which is N-butane, the normal butane. Let's say 1. We have a C, 1, 2, 3, and a 4. Yeah, attach the hydrogen there, attach the hydrogen there, attach the hydrogen there, attach hydrogen there. Good. This is the hydrogen. That is normal butane. Then the other one is what? We have said draw and name 2 structural forms of the compound. The other one is a branch one. So let's say number 2 here. We'll come to the naming. Number 2 here, let's see how it can branch. Okay, we have 1, 2, and 3. It can either branch up here or it can branch down here. So let's put it down where we have some space. Or we can still put it up where we have some space. No problem. We have a C here. Yeah. Yeah. We have here. We have here. Yep. Yeah. We have here. We have here. Yes. And this other one. So now, if we are to draw this structure here, and we want to name them, let's see the principle of naming this compound here. You will see that in naming this, there's no branching, so we have just 4 is a normal butane. This is N, we call it N-butane. N-butane. This is N-butane. And again, if we want to name the second one here, this let's start numbering from this end. If we say this is carbon 1, and this is carbon 2, and this is carbon 3. Okay, you can see your carbon 3. Well, what we can say is that it's 1, 2, and 3. The methyl group is located on the second carbon, so we can now say it is 2 methyl. How many? The parent compound is what? How many carbons are there? 1, 2, 3. So our name becomes 2 methyl. 2-methyl propane. So it's 2-methyl propane because the methyl group is located on the second carbon atom. So that is how you can draw this structure. The one is N-butane and the other one. So now let's go to what name is given to the structural forms. Of course, as I told you that you should know how you can differentiate between the different forms of molecules having the same molecular formula but different structural forms. We call them isomers. That's why I say you should be able to know how to differentiate them between isotopes and allotropes. So we call them isomers. These are isomers. These are isomers. Isomers is the name given to them. Isomers. They are isomers. Okay. Now, question number, excuse me. Question number, the C part of it. Write a balanced equation for the combustion of methane. Learners, I also want to remind you that you should know how you writing balanced equation of all this because they are always required, especially in your calculations. A balanced equation for the combustion of methane. You can say, okay, now we have methane here as C form. This is C form. Good, and H10. That is methane, and it's usually liquid or a gas. It's usually liquid or a gas. Yes. Yeah, it's a liquid. Yep. Plus oxygen. Plus oxygen, which is a gas. When it reacts, what becomes the product? The product, if it is complete combustion, a balanced equation for the complete combustion of methane. So it will give us a carbon dioxide. But if it is an incomplete combustion, it is carbon monoxide. So now we have carbon dioxide, which is a gas, and carbon monoxide and a molecule of water that is being released. So water is released, a molecule of water that is being released. Okay, now balancing this equation using our the number of moles, we have hydrogen. Let's start with carbon. The number of carbon here, you always start with carbon. Carbon here is 4. So what we need here is a 4 number of carbon. Okay, now when you finish with carbon, you go to hydrogen. The last person you balance is oxygen. Go to hydrogen. We have 10 hydrogens here, and the hydrogen here are just 2, so we need a 5 here. Now the last person, as I said, is oxygen. Oxygen, now we have 5 oxygen here, and we also have 10 oxygen here. So 2 times 4 is 8. 8 plus 5 is like 13. 8 plus 5 is like 13, and we need something to multiply by 13. We need something to we need a certain number. Oxygen here we have what? Oxygen we have 2 times 4 here is 8, and 8 plus 5 is 13. 8 plus 5 is 13. What number can we multiply by will give us 13? The lowest number we can multiply by will give us 13. Okay, if we multiply these two, what number can we multiply these two by? That will give us a 13 on the right. So it should be 7.5. And since we don't usually balance equation by decimal, we will use about 13 all over 2. It should be 6.5, sorry. 6.5 will give us 13 over 2. So it will be 13 all over 2. Don't write 6.5. Use a fraction. So that will be our equation for the complete combustion of methane. So that is complete combustion of methane. Now let's go to give one domestic use of methane. One domestic use of methane. Methane is used as a cooking gas. Methane is used as fuel for the kitchen. So the fuel used in the kitchen, we can write it as okay. So I can say here lastly that butane gas used as fuel gas for the kitchen. It is used as fuel gas, the fuel gas for the kitchen. It's used as fuel gas for the kitchen. So you can use it in cooking. So fellow learners, this is we'll be coming to the end here. We will continue with the other section of paper 2 when we come back. So thank you very much. Thank you very much for watching. Once more, if you haven't subscribed to our channel, please make sure you subscribe so that you are going to be having all the subsequent videos that will be coming out. Thank you very much. Bye-bye.